This video will cover industrial hygiene and specifically the hazard of occupational noise exposure. So what is industrial hygiene? Industrial hygiene is a broad field and can be defined as the science of protecting and enhancing the health and safety of people at work. Industrial hygienists anticipate, recognize, evaluate, and control hazards. For example, an industrial hygienist has a strong background in the many different manners in which workers can become injured or develop illnesses. That is, they anticipate injuries and illnesses. They are also able to recognize hazards within an environment. Mixing chemicals together that are independently harmless but can result in a toxic vapor when combined is one example of how an industrial hygienist can recognize an unforeseen hazard. To evaluate the hazards, industrial hygienists measure the intensity or concentration of an exposure, compare that intensity or concentration with applicable governmental regulations and recommendations from organizations that research such hazards. Finally, the industrial hygienists develop a plan to control the hazard. Strict procedures for removing asbestos from older buildings, such as the proper personal protective equipment that should be worn, is one way that an industrial hygienist might control a hazard. Some examples of hazards that are regulated include lead, benzene, and asbestos exposures, also inhalation of coal dust, and what we will be discussing in more detail, occupational noise. There are several industrial hygiene organizations that help protect workers from hazards. First, industrial hygiene regulations are passed by the Occupational Safety and Health Administration, or OSHA, which sets limits on the quantity of exposure acceptable to the worker. These acceptable levels are called permissible exposure limits, or PELs. Unfortunately, most of these PELs have not been updated since 1970, when OSHA was formed. Our knowledge about how the body responds to chemicals and other hazards has advanced substantially since 1970, with new funding for research and better technology to assess long-term health issues. Therefore, two other organizations are important players within the field. The National Institute for Occupational Safety and Health, or NIOSH, and the American Conference of Governmental Industrial Hygienists, or ACGIH, both publish guidelines for employers to follow to protect workers from hazardous exposures. While these guidelines are not always mandatory by law, they are widely viewed as the absolute best way to prevent employee injuries and illnesses that result in large costs to businesses and workers. Occupational noise is a major concern for workers, with 22 million workers exposed to potentially damaging noise each year. $242 million is spent annually on workers' compensation for hearing loss disability. OSHA has set a permissible exposure limit, or PEL, of 90 decibels for 8 hours per day of work. Decibels is normally abbreviated dB, but the A refers to a scaling put on the noise that more closely mimics the function of the human ear. In other words, the devices that are used to measure sound apply this scaling so that the industrial hygienist can get a better understanding of the danger posed to the worker. Although OSHA has set the regulation at 90 dBA for 8 hours, NIOSH recommends workers to only be exposed to 85 dBA for a workday in order to avoid damaging hearing loss. Noise is measured by one of two primary devices. The first is the sound level meter, shown on the left. This is typically used to measure the noise within the area in which the worker works. By measuring the noise in the environment, the industrial hygienist can assess areas requiring hearing protection devices, as well as sources of noise that should be controlled if possible. The second device is referred to as a noise dosimeter. A noise dosimeter is worn within the hearing zone of the worker for the duration of his or her shift, as shown on the right. This gives the industrial hygienist a close estimate to the actual noise level the worker experiences for the entire shift. If the worker moves around the facility or rotates job, the noise dosimeter captures those differences in noise exposure. Later, we will demonstrate the use of a sound level meter for measuring noise produced by different air nozzles. Noise can be controlled in several ways. The source of the noise can be enclosed with sound-reducing barriers. The workplace can limit worker access to areas of high noise through posted signs and locks. Hearing protection devices, such as earplugs, can be mandatory for workers. If possible, the source of the noise can be eliminated, such as purchasing a new machine that has been designed to produce less noise. Preventative maintenance on machines that rattle or vibrate can reduce noise exposure in some instances. Last, the employer can purchase tools designed for noise reduction, such as the air nozzles we will view shortly. Some questions to consider when deciding on how to control noise are which method is the best, and are there trade-offs associated between different methods of controlling noise? One common form of loud noise in the workplace is air nozzles. Air nozzles shoot air at a given pressure and can be used in several different ways, such as brushing chips off products. The experiment you are about to see was originally conducted because a local peanut processing company had workers complaining of noise from the air nozzles while they blew peanut shells into waste receptacles. The next videos will show us in the lab with 3 different air nozzles. The first air nozzle does not have any design feature to reduce noise. The second air nozzle has a moderate design to reduce some noise, and the third air nozzle has been designed to reduce a substantial amount of noise. This nozzle doesn't really have any engineering design in it as far as trying to reduce noise. So this one should in theory be our loudest air nozzle. So the sound level meter is 10 feet away from me. I'm going to shoot it for a few seconds and then we're going to get the reading for how many decibels of noise that the worker would be exposed to at that distance. Alright, this is our second air nozzle. This one does have a special tip here that's designed in order to reduce the sound levels. So now we're gonna do the same thing as we did for the first one, and we're gonna see if there's any noticeable difference between the two in sound output that would be experienced by the worker. Alright, so this is the last one that we're going to be testing. This one you can unscrew and screw on different nozzles depending on the performance that you need out of it, so what pressure levels you actually need. So if you need a higher pressure level, you can just screw on a different nozzle that's still designed to reduce noise, but won't give you the maximum noise reduction that you'd be able to get from a lower pressure level. So we're going to do the same thing.